Hello friends, let's examine the pressure sensors we use to measure pressure in our work today. In industrial applications, we generally need to measure and control pressure in pneumatic systems and hydraulic systems. The sensors developed to measure these are called pressure sensors, pressure transducers or pressure transmitters. If we examine the sensors in my hand, as you can see, there is a part at the end for connecting to the system. We connect the pressure in the closed containers to the system to be measured from the following part. We have a connector on it. Let's open it like this, or there is already one opened as you can see here. We also get the output from the connectors from here. We also provide the feed from here. Let's examine a newly purchased sensor that has not been used in my hand. It appears to be high pressure in the sense that it can measure pressures between 0 to 600 bars, that is, suitable for hydraulic systems. If it was pneumatic, the upper limit would be lower. Apart from that, it is written that the output current is 4 to 20 milliamperes. The supply voltage is seen to be between 10 to 30 volts. As you know, since we usually use 24-volt DC supply in industrial automation, it meets these limits and stays between the limits. The meaning of the output current is that when the pressure applied to our sensor is 0 bar, we will be able to output 4 milliamperes, and when the system pressure reaches 600 bars, the same sensors that will give us 20 milliamps output are also available with 0-10 volt output and 0 to 20 milliamp output. However, we will have 4 to 20 milliampere sensors with which you can measure the most reliable and most accurate. Let me try to explain it this way. Types that give 0 to 10 volts output make accurate measurements at close points, but when we want to carry them to long distances, we may read incorrect values because voltage drops will occur on the 0 to 10 volt cable. We also read the correct values with 0-20 milliamperes, that is, independent of the cable length, but when the cable breaks or the sensor fails and cannot output, the system will take it as 0 bar as the controller system pressure, so we get wrong information. In the case of 4 to 20 milliamperes, when the cable is broken or the sensor is broken when we can't get an output, the controller will detect it and this will generate an error code, not 0 bars. In this case, it will be possible to find and fix the error in the system, so that we can prevent some accidents. That's why sensors with 4 to 20 milliamps output would be a better choice in such applications, I personally think. Let's examine how the connection will be now. Usually, when we buy such sensors, a paper comes out of it. The connections are described here, but the connection principle of the current outputs is generally the same, just look at the numbers. Let's call it 24 volts DC. Let's draw the sensor here, whether it's number 1 or number 2. The connector is usually connected to 2 of them. We go to number 1 like this. Let's put the plus of 24 volts here, or if you want to put our milliamperemeter here, whether it's plus and minus. This controller can also be the analog input of the PLC from number 2. Again plus we go to the end. We take the minus end from here again. We connect it to the minus end of the power supply. So we have established a series circuit. This is a current of 4 to 20 milliamperes. Of course, we mentioned that the sensor we have is 0 to 600 bars. Of course, this is 0-600 bars and this is a unique value for this sensor. There are different values in different sensors, or we prefer a suitable sensor for our purpose. In our next study, let's connect our sensor to the system and connect the control device on it. Let's process it either in the control device, in the SC or in PLC at work, and try to control the compressor that will create the pressure source here, or to keep the system pressure within certain limits. I hope this information was useful for you. See you in our next work.